Hello and welcome. In this tutorial, we are going to use the gravity speaker and the light sensor to make a light theremin. Now, we have a voltage divider set up there. We're going to use the DF Robot light sensor. We're going to plug it in like this. So we're going to need to do some reshuffling on the circuit. We're going to need to pull out all these wires so we can house the gravity shield. Maybe, just maybe, I can zoom this in for you. Merge, so you can see it better. So we plunk this guy straight on. I just love the way this guy works. And we can use a PWM pin, perhaps, instead of having that LED blink, or maybe even together with that LED, we can find I think a 6 would be, so it's 0, 1, 2, 3. Yeah, it already kind of works. 0, 1, 2, 3. 4, 5, 6. So the green would be there. Just to make sure that I got, this would have to be turned around. And there goes the sensor. I would need to also connect the 5V and the GND as well as that LED. So the 5V and the GND, actually, you can use this part of the shield. The GND is the first, so the GND can go back there. And the 5V can go there. And last but not least, we can get that 0, 1, 2, 3. So we need to also have a reading of this light sensor, and that's going to be interesting. Sorry, the LED, yeah, LED was at 3. And the reading was at a 0, right there. Sort of taking the reading from my hand here. But that guy should go in together with these. So right now when I re-upload the very last, and I'm going to go back into the view, merge. So you see this this code right here. This was the self-calibrating light sensor. That LED should go off. And the more we do this, the brighter the LED is going to get. Now, the reason I'm still having this LED is it gives me some visual indication of what is going on. What I'm going to do is I'm going to add the loudspeaker to the program and see if I can create a light theremin. So I'm going to call this int speaker, and we're going to have the speaker on at pin 6. We're going to need to set it as speaker is going to be an output. And while all this is happening, we're going to have to get rid of the serial printing. It's just going to be no room for that. We're going to have to get rid of these delays. And we're going to have to try to figure this out on our own. So the reading is initially 0. So I think that LED power should be the speaker power. So we can also analog write speaker, comma, LED power. And then we can make some delay. Maybe make a small delay. Then we analog write, oops, speaker to 0, and then we make that same delay. Speaker to 0. And then we make another delay of 1. So this should have the speaker go on at a sort of constant frequency, but the loudness is going to get higher as we shade that sensor, hopefully. We no longer have any serial, but watch. Pretty cool. And now let's see if we can change the frequency. See this delay? We can delay microseconds, and we can put in the value of the speaker there. Now, sorry, the value of the LED power. However, we may have to multiply that a little bit. Delay microseconds, I'm going to put in LED power. And see how this works. I suspect it's going to be inaudible at first. So at low frequencies, it's not that cool. So what if we times that by 10? Times that by 10. What's the maximum LED power? About 500. So that'll make it about 5,000. Let's see how this works. So, I'm just curious, if I used a light-dependent resistor instead of that photodiode, would we get a different result? Get in there, son. That's gonna restart the program, hopefully. There is nothing. Okay, need to re-upload. Pretty cool. And I'm just curious if instead of microseconds, we delayed LED power. I almost feel like plugging out the loudspeaker. So if you just want to get some peace and quiet while working on something potentially annoying to your ears, you just upload a blank program. So what I want to do is I don't mind the speaker power being there. I don't mind what it is. But I do think that we can do something with the frequency. And I'm going to go int fric equals to 0. And I'm thinking that we can calculate frequency to be some variant of the LED power. So frequency, let's say it's LED power. I'm gonna try dividing it by 10, and then I'm going to so right now the frequencies have gotten, we don't have the extremely high frequencies anymore. There could be an issue with converting this, you know, the delay may have to be an integer, but it may also automatically convert to an integer. That's not too bad. And file, new, blank me. Okay. And just one last thing. If you wanted to shift the power to something consistent, let's say 800, would we get a sort of cleaner sound at least? That's what I'm curious about. Okay, that's all the experimentation I'm going to do. I suggest you make this your own, you build it, and that you have fun with it. Try both the LDR and the photodiode. They give slightly different effects. The photodiode is a lot more precise, has a lot more range, but somehow in this experiment, the LDR I think gave us a slightly smoother sound. So there you have it. See you in the next tutorial.